Next, I would like to invite this Gary Gao from our microcontroller team. So Gary will be sharing our latest MSP M0 portfolio to enhance overall system performance and most importantly, helping you guys to lower the system costs. Gary, yeah, okay.
Hello, okay. Let's start. Okay, thank you everyone to come here. I'm Gary Gao, and I'm come from Shanghai, and I'm the application engineer in the MSP product line in TI. For our product line, we are focused on the MCU products. Today, I want to share about our new MCU product families. It's named MSP M0 series family. And this is the new product family here. Before this device, our product is focused on a very old MCU. Maybe you are used or hear it before. It is named MSP 430. Okay, it has 30 years old products, very old products. So it is not the topic today. So I want to introduce our new product family here. Is MSP 430. Sorry, MSP M0. Oh, sorry. Here is the agenda that I want to share with you. Is that I want to introduce our new products, key features, and our roadmap of our new family. Second is that I want to introduce one page of our hero products. And then I want to highlight the analog peripherals on this device. Then, as you know, the MCU will need the software, so I want to introduce the software resources I can provide for you for your designs. And then I will introduce our target markets with our products, and then I will introduce a special using case that to replace the discrete components in your design. And at last, I will introduce something in the TI.com, which resource or something I put it in the TI.com and what you can get there. Okay. Let's get started. First, the key features of our new products, MSP M0. First is that the core of our MCU is based on Cortex M0 Plus. It is 32 bits CPU. It is different with our old MSP 430. It is 13 bit MCU. So first feature I want to highlight here is the cost. We have do many works to cut down our cost of our MCU. For example, we take the process of 65 nanometer process. It is not the most advanced process, but it is advanced in MCU markets. As you know, in current MCU market, the normal process is more than 90 nanometer. So we have some advance here to use the 65 nanometer process. That will make our die size will be smaller and cut down our cost here, and we can provide a lower price for you. The next is that we use the smallest packages on our device. That means our cost will be lower, and you can make your PCB will be smaller and the cost will be down from you and us. So that is the point here. The second thing I want to share is our scalable feature on our device. We have a big roadmap on our device. As you can see here, it is I just listed the few features here. Like we have 8 to 128 kilobytes, the memory size of it, and we can cover the pin count from the 16 to 64 pins. It is just the current products here. We also have roadmap to a large range than this. Okay. The other key point here is that our products are all pin-to-pin compatible if you are using the same package. From the different, we have different device families I will introduce later, but it also can be pin-to-pin compatible if you are using the same package. So that is very convenient to use it as a platform. You can use it as different of application or projects and just make a few change of the hardware. So that will reduce your design time and cycles and make your product to be fast to release to market. Okay, if you are your application will related with the automotive, we will also provide Q100 qualified devices here. And the third one is that our device is very easy to use. As I mentioned before, our product line has focused on MCU products for more than 30 years. So we have a lot of experience to show you to customers how to use MCU very easy and fast to start with your products. For example, we have provide lots of examples that to show our peripherals how to use it, and the other is that we have provide the code generated tools that if you have not used it before and not very clear about familiar with our APIs or peripherals, but you can just use the GUI and just make some double click on our tool, and it will help you to generate the code itself. Okay, so that is very easy to start to use. Okay. Here's our roadmap here. As you can see, we have provide two device families here. The first is G series device. It is a high performance device family here. As you can see, the main frequency has up to 80 megahertz. The other is that for the G series device, it has not mass product yet, but it will be happen next month. But you can get the samples on TS.com. For next family is L series family. It will be lower main frequency and low price. Lower price, yes, and it has been mass produced now, so you can use it in your project and buy it in the TS.com. Yeah. On the right here in this table, I have listed all the devices here we have released to market. As I mentioned before, the pin count, as you can see, we covered from the 16 to 64. and the memory size from the 8 kilobytes to 128 kilobytes. It is just the latest product we can provide, but we can provide more in future. Like we can provide 12 kilobytes in future, and the pin count we can cover to up to 100 pin count in future. That is the roadmap in our future. Okay, as you can see, I separate the products for 3 colors here, and in the blue one is the L series device, and the right one is that the G series device without the CAN interface, and the yellow one is the G series device with CAN FD. The CAN is the CAN FD featured. The CAN FD devices here. And at the bottom, I have listed some naming rules our devices that, as you can see, at the middle of the device number, it is the information of our scalable analog information of those numbers. Okay. Here's our product one page. Here I will not go through all of them due to the time, so I just highlight a few points here. Like, first is that as you can see our operation temperature we can cover from minus 40 to 125 degree. That is automotive level. But we can provide that in industrial products. So that's a large range temperature operation. There, the other point I want to highlight is that is our, as you can see here, okay, let me see the UART, the UART peripheral. It is very powerful peripheral here. It not only can be used as a normal UART, it can be transformed to like LIN or IRDA interface or DALI interface, Manchester featured, and it can also be used as smart card detection. Okay, for the I2C module, we also provide, you can use it as SM bus or PM bus. We can provide the PM and SM bus libraries that you can use here. The other thing I want to highlight is our analog peripherals on our device. First is ADC. The key point here of our ADC is that the knob, we can reach our knob bit to 11.2. That is a very good spec compared with our competitors. The next is that we have zero drift choppered amplifier on our device. It is chopper technologies and make the input offset to be 0. Yeah. Okay. For this device, I just highlight those few points here. And the next is about our G series device. It is our performance device family here. The main difference with our L series device, as you can see, the main frequency is increased to 80 megahertz, and we have enabled the MPU unit in the Cortex M0 Plus core. And then to improve our counting capability, we have added mass accelerator here that you can use in most application like mode control to use FOC algorithm. Yes, I can. So you can use the mass accelerator to do the counting process. Okay. The next is about our memory. Our memory are all ECC protected. At here, that yes, the ECC protected. Okay. Next is that the difference with our LCS device is that the G series device supports the external oscillator, both low speed and high speed. And also we have powerful UART here, and for the interface, the key feature of this G series device is that for some device we have the CAN-FD interface here. Yeah, you can use it in industrial CAN or in automotive CAN interface. So you can select this device. For in the analog peripherals, we have improved the performance of ADC. The main difference is the sample rate. We have increased our sample rate to 4 meg SPS. That is a very high speed than our competitors. And then we have add 12-bit buffer DAC. You can use it as analog output in your application. Due to this device, as I mentioned, we for one of our target market is mode control. So we have add a few features in our timers to support the mode control. Like we have added the deadband control on the mode controller system, and the QEI detection. Okay. Yeah, that is overall of our G and L series one page. Next is that I want to highlight is our analog peripherals on our device. As you know, TI is very large market share about the analog, and our analog technology is very advanced. So we have put those on our device also. First, I want to introduce our OPA. As I mentioned that the one important key point here is that we make it zero drift, that is chopper technology based. The other is that it also with PGA, that is a programmer gain part here. You can change the gain value to up to 32 times at the runtime. The other is the ADC. I mentioned that we can make the sample rate to 4 meg SPIs. So if you are using the oversampling technology, you can increase the bit to 14 bits. Okay. Next is for some devices, we will have the competitor. And this competitor will include a 8-bit DAC included there. And you can set the different threshold at runtime to use with the competitor. The last one is the DAC. Okay, sorry. Our DAC is 12-bit, and overall, I want to highlight is that the peripherals is that you can connect the different of the analog peripherals internally just by coding in the device. And that can avoid layout outside and make your PCBs be smaller and avoid maybe some EMC issues in your designs. Okay, that is key features of a peripheral. Okay, next is that is our software information is here. I know as the MCU products, you must to do the program on the device. So the software is a very important part in the MCU development. First is our is that the SDK, the software development kit here. That SDK will include all the resources you needed to develop the MCU design, like the peripheral, every peripherals code examples, and our reference design code examples, we have all put there into the SDK. And here listed feature I want to highlight is that our SDK code is optimized about the code size. It will be much smaller than our competitors. That will cost lower or smaller flash size on your device. The second is that if you want to evaluate our device, we can provide the hardware, lots of hardwares you can use, like the Launchpad or boot pack you can use. For the Launchpad, as you can see, there are two main devices here. The upper one is our debugger. It is ActDS110. So you can just connect the port with use USB cable to the PC, and then you can get started to debug or coding the device. So that is very easy to use with hardware. So the second is the third one is that very important part is our tools. The code generator, as I mentioned before, it named the sysconfig. You can use this to configure our peripherals. Just use click selections of the tables, so it can generate the peripheral configuration and code itself. And I will go details about it later. Okay, the last one is that the third-party software we can support it. As you can see, we can not only support our IDE like CCS, it is free for you, but also I can support the IR or Q, the IDEs, and also we can support that many other third-party software like FreeRTOS or Artistride and support and so on. And if it can support the M0 Plus core, you can use it. Okay, here is the detailed information about our SDK. As you can see, our SDK codes are based on the standard of CMSIS that is come from ARM. Based on that standard, we developed the driver lib. It is functional APIs to operate the registers. So you do not need to operate the registers directly. You just need to call our APIs, different APIs, to configure or operate our peripherals. Based on the driver lib, we have make the multiple code examples for every peripherals for many of operation modes of our peripherals. We have provide many of code inputs there. Beyond that, we have developed many reference code based on different application areas like mode control or automotive. We have built hardware designs and software codes there that you can get to quick start with your projects. If you have not used our device before, we have also provided a lot of training materials for you, like the MSP Academy and the TI Prison Labs. TI Prison Labs is a video training series materials. And for the MSP Academy, it is will provide you few lives and introduce our. We have picked up some of examples there and introduce the example, and you can do some lives with that, so you can quick start with it. Our device. Next is our code generator tool named sysconfig. As you can see here, we have put all the peripherals in our sysconfig tools. You can configure any peripherals with these tools. You can just make few of the click on this GUI, and it can generate the configuration code for you here. Here you can see. The one point here I like it very much is that it can preview the code at real time. What I mean is that if you make any change of the GUI, like here, if you make any small change of it, the code will be changed at the same time. That means you can, that is very convenient for you to debug or start learning how to code our device by yourself. Okay. Here's our security feature of our device. We have provided a demo named BIM, the Boot Image Manager demo. That means this demo is used for that it can avoid the MCU to run any code had been modified by a hacker. If it had been modified, the application code will not be run. We have provided the code examples and the application document in TI.com. If you are interested with it, you can go through it in the TI.com. Okay. Here's the main markets we are target with our device here. As you can see, we in our define our device. Our device is a very general purpose device, so it is not limited to those target markets. This just our focused market we are looking at. As you can see, the features that I have mentioned before, so I will not go through them here. The one point here I want to highlight is that we have provided lots of reference designs, both hardware and software for those application market. I have listed a few of them at the bottom of the market here, and if you are interested with that, and you can also go into our TI.com and get those reference designs to start with the application. So that's rough designs will quick start with your application product if it is similar with your using case. Okay. Here is a special using case of our device is that you can use it to replace the discrete components on your old designs. Why our device can do this? First is that I have mentioned we have cut down our production, so we can provide a lower price for you to choose it. The second point is that our device is very flexible. Flexibility. I have mentioned before, we have plenty of devices, roadmaps there you can select for your application with a proper device. The other is that, as I mentioned before, it is you can code your the MCU can be coded, and you can change the functions at the runtime. That is, a discrete component cannot do that. Okay. The third part is that, as Robert mentioned before, we have built lots of new fabs in US, so the supply is our advantage here. This is our new family, so we have put it in our device in the new 5 series, so the supply should not be the issue in the future. The last one is that the MCU is for free. What that means is that for the discrete components, it will not have an MCU. But for our MCU device, we not only have the analog peripherals, we have provide timers or watchdogs, such peripherals on the device. You can use it to create new functions on your application. So that is not provided from the discrete components. Here's just a very simple example here to use our device as a bridge device. You can convert the UART, not UART.SPI, to UART.I2C or CAN interface or analog signals here, and you can also use it back and vice versa. Here is some information about our device on the TI.com. If you have the specific device name or the part number, you can just search it on TI.com directly. But if you do not have the part number, you can go to our products and microcontroller column, and then go to the ARM Cortex M0 Plus device MCUs. Then you can go into our plus page here. The very useful tool here to select device is that the filter here. You can input your requirement for different requirement based on your application, and then it can select a proper device in this column for you, and then you can go into our product page at here. And then this page will provide all the resources you needed to develop your design. Or tools, it include tools, documents, and all the resources I mentioned did not show here. Also include some packages information or design reference you can get from here. for documents like the datasheet or user guide or TRM, you can get from this product page. Besides that, all the reference designs, application notes, also you can find here. Also the software tools like the CCS, sysconfig, and something like that, you can also get it in this page. Okay, that's all I have. I don't know if any questions about our product line. No. Yeah. Yeah, you're right. Yes, you're right.
M0 support this chipset.
Yes, you're right.
But at the same time, I saw that you're using the sysconfig, right?
Yeah, it can combine into the CSS.
Okay.
Yeah.
Then there's another one that is the I think last time I used the code generator, the HAL code generator.
Yeah.
Does it support this M0?
Yeah, you're right.
It is also supported.
You mean sysconfig, right?
No, the other one, the HA's code gen, cat gen.
Oh, no. I just support the sysconfig.
Okay.
Yeah.
Okay. Thank you. Yeah.
Okay, thank you.